we are going to talk about probability. We've talked about probability before. We may see some problems that are a little bit more difficult than you did last year. But you guys have been working with probability since what? Grade school? Probably you started talking about it. Okay. So some of this is going to be review. We're going to talk about some vocabulary that you may or may not remember. A lot of our examples are going to deal with cards, spinners, and dice. Okay? And marbles for some reason. So here we go. Let's go through some vocabulary. Okay, when we say experiment, okay, any happening for which the result is uncertain. We don't know what's going to happen when we roll a die. We don't know what's going to happen when we pick a marble out of a bucket. Okay, it's called an experiment. We don't know what's going to happen. We call what could happen from that experiment an outcome. Okay, so our outcomes, I could roll a 1, I could roll a 2, I could roll a 3. Those are the different outcomes from our experiment. Sample space. This is an important one. What is a sample space? Have you heard that term? You have not heard the term sample space. Anybody have an idea? A collection of all of the outcomes. Okay, so what are the different outcomes of an experiment? So the sample space for rolling a die would be 1, 2, 3, 4, 5, 6. Okay, so we're going to get a little technical here as we define probability, okay? An event is any sub-collection of a sample space, whether it be rolling a 2, okay, or rolling evens, okay? It doesn't have to be just one outcome. It could be a subset of outcomes, meaning just a portion of them, okay? Which means the probability of an event would be the number of outcomes over the number of our sample space. Okay, you've known how to find probability from, way back in grade school. Okay, but this is how we are going to define it. Okay, so event E has a certain number of outcomes, and our sample space has a certain number of outcomes. So the probability is the number of outcomes we want over the number of outcomes in our sample space. You know that. Okay. What is going to be tricky sometimes is figuring out how many outcomes are in your sample space. Okay? Rolling a die just once, not difficult. Flipping a coin just once, not difficult. Flipping a coin 5 times is a little tricky. Okay? Rolling more than one dice. You have to think a little bit about that. Okay, so I will show you a trick for finding, for flipping a coin to get that sample space. Okay. Tossing one coin, not hard. What are our 2 different outcomes? Heads or tails? We could get heads or we could get tails. How about flipping a coin 2 times? What are the different ways that can happen? I could get heads and then another heads, or I could get heads, tails, or tails, tails, or tails, heads. Because it's a different order. Okay, so there are 4 different events in our sample space, but as I said, what's the probability of getting 1 tail and 1 head? What would that be? Well, there's 2 outcomes that are 1 of each, so the probability of getting 1 tail and 1 head would be 2 out of 4. Okay. Which you would reduce to 1/2, of course. But okay. What about the probability of tossing 3 coins? How many events do you think are going to be in our sample space? 8? Okay. Let's see. My advice to you would be to make a diagram, okay, of what could happen on your first toss, what can happen on your second toss, what can happen on your third toss. So our first toss we could do what? Heads or tails, right? So our first toss we're either going to get a head or a tail. Okay? Our second toss we're either going to get a head or a tail. So from here we're either going to get a head or tail. After this first toss, we're either going to get a head or a tail. Okay? Our third toss is either heads or tails. So from here, it could be heads or tails. Here, it could be heads or tails. Here, it could be heads or tails. And here, it could be heads or tails. Okay? So now, we have each possibility for our 3 flips. We're either going to get head, 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 heads, heads, tails, heads, tails, heads, heads, tails, 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 heads, heads, tails, heads, tails, 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 heads, and tail, tail, tail. Okay, so there are 8 in our sample space. Okay, now we may have known that, but getting all 8, if you try to sit there and just write them out without the tree diagram, could take you a lot of time. Okay, especially if I talk about maybe 4 flips or 5 flips. Okay, so anytime you have a choice like heads or tails, or when you're talking about like a litter of puppies, it could be a boy or a girl. Okay, maybe there's 5 puppies. Okay, anytime you have a choice of one or the other, a tree diagram is very nice. Okay, so use a tree diagram to help if you want. Okay, probability. What's the lowest it could be? What's the lowest the probability could be? 0. What's the highest it could be? 100%, right? So our probability could be between 0 and 1. Okay? Because when we find probability, we're finding the decimal, right? And then you can write it as a percent after that. Okay? If our probability is 0, that means our event cannot occur. It's an impossible event. Rolling a 7 on a 6-sided die is impossible. The probability is 0. If our probability is 1, that means it is a certain event. If I say what is the probability, I'm going to roll an integer. When I roll a die, that is going to be 1. You are going to roll an integer every time. No matter what, it is certain that it will happen. Okay? Do you remember this word, complement? What does it mean in probability? If event A has this probability, what's the probability of the complement? 200. Getting a lot of blank stares here. Okay. The probability of A and the probability of the complement of A should add to be 1. Okay? So the probability of the complement is just 1 minus the probability of that event. Okay? So the probability of rolling a 2 is 1 out of 6. The probability of not rolling a 2 is 5 out of 6. Those two are complementary events because they add to be 1. Okay? They're opposite. You either roll a 2 or you don't roll a 2. Okay? Sometimes it's easier to think about the complement. If I asked you to find the probability of not drawing a king when you pick a card out of the deck, okay, it is easier to think about what is the probability of drawing a king, and then we could subtract that from 1. Okay, so what is the probability of drawing a king from a deck of cards? 4 out of 52. So the probability of not drawing a king would be 1 minus that, which would be 48 out of 52. Okay. I'm going to give you some symbols. Okay. The union of two events we symbolize with this U. Union. It means A or B. The union means or. If we have an empty event, that means the event has no outcomes. Okay, and the probability of an empty event is going to be what? 0. And then finally, this upside down U means that our two events are intersecting. There's overlap, or you can, or there could be overlap, I guess. In our terms, it means and. So the U means A or B. The upside down U means and. A and B. Okay. If A and B are disjoint, we write that A and B is empty. Okay, what does that mean? If A and B do not overlap, they don't have anything in common, then when their overlap is going to be empty. If they don't have anything in common, they're not going to overlap. Okay? This is kind of foreshadowing to what we're going to talk about next. Okay. You remember all those ands and ors you had to do with probability last year? Okay, I'm going to remind you of our rules. Okay? But basically, you need to remember that this U means or, this upside down U means and. Okay, so those are some new symbols that you're going to see in your homework. Okay, now I want to talk about the union of two events. Okay, I want you to look at these two pictures right here. These two pictures right here. Okay, we're going to start down here with this picture. So here is my sample space, here is event A, and here is event B. Okay, when we talk about the probability of A or B happening, we have to think about whether they are mutually exclusive or not. Okay, mutually exclusive means they are disjoint or they cannot happen at the same time. If two events are mutually exclusive, then they are separate. There is no overlap. A and B does not happen at the same time. Okay? Yes?
It's like picking an ace.
Okay, picking an ace or picking a 2. That cannot happen at the same time, so they are mutually exclusive. Okay? To find the probability of A or B, you are simply going to add the two probabilities together. Or we think of as addition. Okay, just like we did in our counting problems in last night's homework. Now, if two events are not mutually exclusive, that means they have some overlap, like this first picture up here. Okay, I would like to illustrate something. If I add the two probabilities together, that this is A and B right here, right? This is our overlap. If I'm looking for the probability of A or B, okay, down here what we did is we added the probability of A, which would be here, and then we added the probability of B. So probability of A plus the probability of B. What is the problem there? It overlaps, which means what happened with this overlap? It's counted twice. Okay, I want this whole area, but I can't have that counted twice. So if our events are not mutually exclusive, we still add our probabilities together, but then we have to subtract the probability of the overlap because that happened because we counted it twice. Okay, so we have to subtract out one of the overlaps so it's not counted as double. So what would be, let's stick to our cards because that's the example that Noah gave. What would be an event where A or B would not be mutually exclusive?
Isn't that like drawing an ace and then drawing like hearts?
Right, if I said what's the probability of an ace or a heart, okay, an ace could be a heart. So those are not mutually exclusive. Okay. So we will do a couple of examples. Does everyone have this written down? Whatever you need from it. Okay. So we're going to stick with our card examples. Okay. My first question, what is the probability that we draw one card and it is either a heart or a face card? Now, going back to our cards over here, which one of those are face cards? Jack, Queen, King. Ace is not a face card. Okay? So, are these two mutually exclusive? Okay? These are not mutually exclusive because our face card could be a heart. Okay? So the probability of a heart or a face card would be, what is the probability of a heart? How many hearts are there in a standard deck of cards? 13. So there are 13 hearts. We're going to add the probability of our face cards. How many face cards do we have? Okay, we have 3 different kinds of face cards, and there's 4 of each. So there are 12 face cards. Now, how many of those face cards could be hearts? There are 3 face cards that are also hearts. So we would have to subtract 3 over 52 because we've counted those twice. We counted them here in our hearts and we counted them in our face cards. Okay. So it is a probability. And then you could reduce that to 11 over what? Okay. Now this second example, what is the probability that our card is a heart or a club? Are these mutually exclusive? Yes, they cannot happen at the same time. So the probability of a heart or a club. What's the probability of a heart? How many hearts are there? There are 13 out of 52 hearts, or means we're adding clubs. How many clubs are there? 13 out of 52. We just described half of our deck. Alright, so the probability is 1/2. If you get a probability that is more than 1, you have done something wrong. If you get a probability that is less than 0, you have done something wrong. Okay, let's talk about independent versus dependent. What does it mean to be dependent? Okay, say that again. Okay, an event occurs and it changes what would happen next, right? Kind of, right? Independent would mean you don't rely on something else, right? You're on your own, okay? So when we talk about independent versus dependent events, okay, if 2 events are independent, that means what happens in A does not affect what happens in B. Okay. So as long as events are independent, then if I ask for the probability of A and B, then you can simply multiply your 2 probabilities together. Okay. So what are independent events? Okay. If you draw a marble and you put it back, putting it back is not going to affect what's going to happen when you take the second marble out. Okay. Drawing a card and putting it back. Rolling a die and spinning a spinner. Whatever you roll is not going to affect what you spin. Okay. What else? I'm going for a while. Okay. But as long as event A does not affect event B, then those are independent of each other. Okay. So look at this example. A sales rep makes a sale at approximately 1/3 of all calls. If on a given day, the rep contacts 5 potential clients, what's the probability that a sale will be made with each of the 5 contacts? Okay, so this her making a call, is that going to affect her next call? No. Each of those events are independent. Every time she picks up that phone, she has a 1 out of 3 chance of making a sale. Okay? So what's the probability that she will make a sale on all 5 calls? What's the probability she makes a sale on her first call? And what's the probability of her second call? 1/3. And her third call. And her fourth call. And her 5th call. Right? So she has a 3 to the 5th would be. What's 3 to the 5th? 1 out of 243 chance, which is what, Miranda?
0.00.
Okay. Now, this is not impossible, but not very likely, is it? Right? Probably not going to happen. Okay. We have one more example. Okay. Where you probably are going to feel the most uncomfortable is when I give you problems that involve counting. Okay. Because then you have to think about not only probability, but your counting rules as well. All right. So let's think about this. A class is given a list of 20 study problems, from which 10 will be a part of an upcoming exam. Has any teacher ever done this for you? Okay. Here's a list of questions. This many will be on there. Okay. So you have to decide, do I study them all or just a portion? Okay. So a student decides they know how to do 15 of the problems. What is the probability that they will answer all 10 questions correctly on the exam? They will know all 10 questions. Okay? So first of all, let's think of our sample space. How many different tests could the teacher give? Okay? How many questions does the teacher have to choose from? 20, and she's going to put 10 on here. Now the order of the questions aren't going to matter because he's either going to know them or not. All right? He, she, whoever it is. Okay? Now, how many tests is he actually going to know all of the problems? How do we find that? How many questions does he know how to do? 15. And if he knows all 10 of them, then those 10 are going to be on there. Okay, so here's how many tests he's going to know, all 10 questions. Here's how many tests the teacher can create. What's the probability? Not a very good chance seeing 100%. Okay, sometimes 100% is out of reach. What about at least 9 questions? He wants an A. What's the probability he knows at least 9 questions? So what does that mean? What does at least 9 mean? 9 or 10. So we need the probability of 9 or 10 questions correct. Okay? First, let's talk about the probability of 9 questions correct. Our sample space has not changed. We still have 20 questions in which the teacher's choosing 10. Right? Now, how many ways can he answer 9 questions correctly? Okay, there are 15 questions where 9 of those are going to be on there. And there are 5 questions he doesn't know, and 1 of those will be on there. Okay. Now we've already found the probability of 10 questions correct. What do we do with these 2 probabilities? We add them together because it's an OR statement. All right. They are mutually exclusive because you can't get 9 questions and 10 questions correct on a test. Okay. So let's find this probability and add it to this probability. Anybody have it for me? 0.15 what? Okay. So your chances of getting at least 9 questions is 0.151. Would this be a good strategy if you wanted to get an A on the test? No. It is very, very unlikely that you are going to get an A on this test. Okay? So if you don't want an A, then I suppose the strategy would be okay. If you want an A, you probably should study more questions. Here's your homework. Alright? We're going to spend tomorrow going over some more types of probability questions. Okay? So you need to come in with this homework completed so you're ready to move forward with probabilities. If you have questions, we will take the first few minutes in class to go over those. If you have lots of questions, you should probably come find me.